Good.
Hello, everyone, and thank you to everyone who has joined us early. I can see quite a few people had logged in 10 minutes back, so thank you for that. I suppose everyone is very eagerly awaiting for this session. I can see a few people trying to log in, so we'll just give them a few seconds and we can start in a minute's time. Right, so moving on, I'll just quickly introduce WalkingTree for anyone joining us for the first time. WalkingTree Technologies is a technology-focused company with our core focus on designing and building cross-platform web and mobile applications, performing system integrations, and enabling digital transformation. We also specialize in data integration, data analytics, and migration from legacy to modern systems. Now, today's webinar is part of our series on conversational AI, where we have previously discussed designing next generation apps using GPT-3, fine-tuning GPT-3 for industry use cases, and of course, the challenges and opportunities that lie therein. Today, we, of course, will be elaborating on designing next generation conversational AI apps using Flutter, GPT-3, and DALL-E. Our three presenters of the day, we have Scott, who is our CTO, and he has been a problem solver and an entrepreneur and a technology leader for almost 30 years now. Under his leadership, we have been able to establish a wide range of digital and data analytics capabilities and an enviable client-centric innovation culture. He's also helping our clients and the WalkingTree team with the big picture insights and new thinking that allow them to act decisively in solving challenges, seizing opportunities, and sparking innovative growth. Abhilasha has over 17 years of experience of leading high-performing teams in building enterprise-scale products and applications. This includes over a decade of experience leading end-to-end design and development of sophisticated analytic solutions across diverse industry segments. We also have Shubham with us. He's been with us for almost, 5 years now, and he takes great interest in solving the last mile problems in analytics. He comes with hands-on experience in ensuring continuous delivery of innovative software solutions. Now, before we get down to today's agenda, I just wanted to let you all know that we will be answering all of your questions towards the end of the session. So please make sure that you use the Q&A box to leave any questions, and we'll try to accommodate as many as we can at the end. So over to you, Scott.
All right, good. Thank you, Prince. So yeah, thanks for the introduction of WalkingTree and just kind of the introduction of the speakers. I thought for a minute there you were going to say that Scott's been a problem in the technical community for 30 years. So which is probably an accurate statement as well. But no, hey, welcome everyone. Thank you for spending a little time with us today. We really appreciate your time. And hopefully you'll get some interesting information and kind of get a little inspiration. Very interesting space, right? Conversational AI, among many other things that are happening in the AI space at the moment. But today, what we're going to do is first we're going to just kind of open up with a little recap on large language models. We've kind of been covering this for a few sessions now, and what we'll do is kind of recap there, and then that will. I think you got a box there in the middle, Prince. You want to, I can share too. Hang on. There you go. Thanks. But the next area will be looking at GPT-3, the latest things going on in GPT-3, and especially in the DALL-E and the DALL-E 2 implementation that recently was kind of released. So some really cool things around DALL-E 2 that came out recently, and I know Abalash and Shubham will be covering some of those. Some really cool stuff, and interesting stuff in that space for sure. And we'll specifically talk about it in terms of conversational AI. And then we'll talk about open source alternatives, around GPT-2 and Stable Diffusion, and then we'll kind of end up the session with talking about conversational AI apps using Flutter. So that'll kind of be where we're going for today. That's your little roadmap. So if, as they used to say on planes, hey, this is where we're headed. If you're on the wrong plane, then at least you know now. All right. So, but don't deplane. Stay with us, even if you're in the wrong space. All right. So let's move on to the next slide. Thank you, Franshu. So, as we begin to talk about, really the subjects of, this month's webinar, I think it's appropriate that we just kind of take a step back and look at, a quick recap of where we've been, and specifically around, enhancing conversational AI with large language models. And to start with that, let's take a look. Let's see, Franshu, let's do this. Let me share. Yeah, you got it. Good. Okay. So in terms of, hang on, Franshu, I'm going to make an adjustment here. I think maybe, let me try to share. I think you got a box popping up there.
Yes, I'll just unshare. I'll stop sharing.
Sounds good. Let's see. I just got a new Mac and not all my permissions are, so I'm going to try this real quick, Franshu. If not, I may have to keep you going with that. So let's see. Yeah, sorry, Franshu. Can you keep sharing? I think it's going to kill me and take me out of Zoom. I think I've got to set a permission in my system settings on my Mac, so I apologize. If one of you, either you or Abalash, either one is fine. Okay, good. Thank you. Sorry, guys. New machine, and still kind of working out all my permissions and so forth. But this next area is, that I'd like to talk about is just to remind us a little bit about some of the frameworks we talked about. And what you see here are a few of the popular conversational AI frameworks. RASA, which we use quite a bit. Then you have Dialogflow, you got Amazon Lex, and of course you got Microsoft's bot framework, Power Virtual Agent, and of course, the big guys like, IBM Watson, and then a little more on that, the NVIDIA Jarvis side, really cool tech there, and really, especially optimized for, NVIDIA hardware. And then we got MindMeld as well. So those are a few of your more popular frameworks. And what we'll do next is, oh, wow. Is that just me, or are you guys hearing a little weird sound? Okay. So, so on the next slide, Franshu. This comparison, now, if you were with us for any of the other sessions, but last session specifically, we introduced this little chart, this little frameworks and their comparisons. And just to try to give you a little overview, I'm not going to go through this in great detail. Don't worry. Throughout the webinar, we'll talk about, probably hit on several of these in some form or fashion. But I like this chart because it kind of lets us know that, what the important aspects, and for each of these, they're all really good. It's just a matter of, I tell my architects here in the company a lot of times, it's a matter of, is this the right way to do it? And it's like, well, it depends, right? And kind of the same thing here. It's each one has, they're all really good. And especially, I think they're all pretty good in these major categories when we start talking about, NLU or natural language understanding. So your intents and your entities, and remember, intents are kind of like your verbs, entities are your nouns, and then the next two, the graphic dialogue node management and no dialogue node management, or native code dialogue node management. Those are around. We talk node management, right? And I think Abhilasha will hit this a little more in depth a little later. But that's around making sure that you understand kind of the intents and making sure that the actual conversation is headed in the right direction from a conversational AI standpoint. So when you look at those, most of these do pretty well in those categories. But then there's some trade-offs in each, right? So it's a matter of what the need is as far as, what tool you're going to use. So it all depends. Like I said, we use Rasa a lot because it's open source, and we're fond of that one. But we also use the other tools as well, right? So Amazon Lex, the Microsoft Bot Framework, and a lot of cool things going on in really each of these, right? So if you're on one platform or another, it may be advantageous to stay on that platform if you got a cloud provider, right? So good chart, I think, to just kind of help you gauge what your need is and what's most important to your application. So hopefully this is a good chart for you. I like to refer to it when we're thinking about solutions, when we solution for our clients. All right, and next. And so next, let's talk a little tiny bit about, and I know if you've been with us, we've addressed some of these before, but what are some of the challenges in the existing frameworks, right? So let's just talk about a couple of those. All right, we'll look at those next. All right, so some of the common, just very high level challenges, right, that you see within some of the existing conversational AI frameworks is there's a limited capabilities around these kind of four areas, and that's around medium and long answer generation. So, I mean, you can imagine, the complexities that really go into, providing either a medium, a short, quick answer, maybe easy, right? But a long, more coordinated, medium to long coordinated answer generation is pretty tough. And then around summarization, right? Just having, good AI summarization from, these large language models or these existing frameworks, can be a challenge. And then, the inference-based answers, right? So how do you infer an answer from something? How do you make something logical, provide an answer that's logical and representative of what the conversation or the questions are all about, right? And then really just incorporating real world knowledge into these, right? How do we continuously look at what's going on in the real world and bring that into, our conversational AI? All right, and next. All right, so let's now take a look at some of these large language models, right? So, and first of all, what are the capabilities of some of these? It's things like question answering, reading comprehension, right? How good is that large language model at actually comprehending the data that it's presented with? And then, of course, as I mentioned, summarization is how do you take all that information and really provide a nice, concise summarization, right? And even a larger, more complex summarization. We'll look at some of the LLMs or large language models that that satisfy some of these needs as you look around here. So, and then just general knowledge, common sense reasoning, and then even proverbs, right? Language translations, pattern recognitions, even joke explanations. I think it would have a hard time with my jokes, though my jokes are pretty dry and kind of strange. So I bet it would be challenging for me. But then also text query conversion, then the arithmetic, calculations, and then the larger logical inference chains as well. So those are just some of the capabilities, right? And that's a lot, right, to ask for a model. But some of these large language models, some are better at some things and not as good at some things. So let's take a look next at some of those LLMs and kind of the areas that each are kind of going to give you some strength in, right? So when we talk about open source, we're talking about things like OpenAI's platform, and then Meta's and Big Sciences. So the different GPTs, and then Meta's Ops 175B, and then Big Sciences Bloom. And in terms of that, what we're looking at for those is, those give capability around answering medium to long answer type questions, and do a good job of summarization as well. When it comes to fine-tuning, fine-tuning models on domain-specific data sets for like better domain understanding and language style. So you've got OpenAI's GPT-2 for that, for example. And then we'll talk about GPT-3 a bit later in the next slide as well. So let's look at the next slide. And specifically around these LLMs that have really advanced pre-trained models. So they can be used for things like sentiment analysis, classification, and really the custom entity recognitions. And then, as well as, medium long and then really very long answer type questions. They're really good at inference, have advanced summarization, and then do a good job with text to SQL conversations as well. And that would fall under that of GPT, OpenAPI's GPT-3, as well as Google's Palm LLM as well. All right, and next, Pranshu. Thank you, Pranshu. Appreciate you handling that for me. Then fine-tuning enables you to further customize your output based on whatever your requirement is, right? And when we talk about, in terms of this, there's one platform that really sticks out, or one LLM that really sticks out, and that's GPT-3. So, and we've covered this quite a bit. We've got a few articles, I think, out on this as well on the website. But GPT-3 is really powerful in terms of this. And then, enhancing the performance, with short answer type questions. When you look at that aspect, you've got Google BERT, and Google BERT's, it's a good baseline to work with when, if there are no other critical needs there. And then Distill BERT it's really got fast inference speed, but, compromise on a few percent on prediction metrics, right? So again, it depends on what's important to you and really what your environment looks like. And then you got Roberta, which, it's really good results and prediction metrics. And then, kind of to wrap this portion up, XLNet, and that's good for really handling long range dependencies as well. So, so hopefully these give you kind of a little kind of recap on large language models, on the different frameworks that are out there and available. And I think next what we'll do, I'll turn it over to Abhilasha to dig into a little more detail and kind of start digging into really what our main topic and reasoning is for the day. So Abhilasha, I'll turn it over to you.
Yeah, thank you, Scott. So I'll share my screen. As we started with a recap of the different language models, and we saw in which areas some models perform better than the other. For today's session, our focus would mainly be on GPT-3 and the newly launched DALL-E 2 API. Additionally, we'll also be comparing these two with their peers, you can say, GPT-2 and Stable Diffusion. So to start with, so I will just give an overview of GPT-3 here for the ones who are joining us for the first time. And if you want to like understand GPT-3 in more detail, you can refer to our past webinars where we have also spoken about fine-tuning GPT-3 and the different ways how you can do it. So for a refresher again, GPT-3 is a generative pre-trained transformer third generation model. And it is a neural network machine learning model, which is using over 175 billion parameters and like tons of data from the internet. It has been trained, and that's why we say it is pre-trained, and it is generative in the sense because like the data learns and generates the next. So it establishes the relationship and generates the next text in the sequence. And again, transformer, because it is a deep learning model from the transformer like category. So, and this was developed by OpenAI, and it has been made available as an API for the world to use, because obviously it is not possible for everyone to be able to train a model of this capacity. But now with this API, we have this very strong model available for use to generate content, different types of content, and put to different use. And that's where GPT is such a good fit for our problem at hand, which is the conversational AI. So we'll see like how we can aptly apply GPT-3 to solve and make our conversational AI smart and human-like. So again, this is the basic 3 steps of how a conversational AI handles the conversation. And we saw this in our last webinar where we took the insurance example and we went over these 3 steps, wherein mainly like when you're designing a conversational AI, you would define the different intents or the different topics which the AI can cater to. And then for each intent, there would be specific entities which have to be extracted so that the relevant data can be gathered from the systems and the response formulated in order to have the proper dialogue control. So the conversational flow of the response, what we are giving to the user, makes complete sense and is like very much in context of the complete conversation. So this is how the overall conversational AI would behave or would interact with the human. Now, when we try to use GPT-3 here, so there could be 2 approaches. If we want to make like a generic, completely, you can say open chatbot, where we train the chatbot for the domain specific data by following the fine-tuning mechanism, and we keep it open to like formulate and convey the response. Or if we follow this 3-step process where we would want it to have a like first step of classification, because when we are trying to follow a structure and not leave it open conversational. So for that structure, the first step would be the intent matching. Now, intent matching is nothing but it is a classification problem wherein we need to identify the topic of the conversation. So like for example, if it is a insurance example, so whether it is a claim request or a policy details like eligibility query. So depending on the first question of the user, the bot has to identify what is the intent, and that becomes a classification problem for GPT-3. So we can fine tune our model to have the different types of prompts which we can expect from the user and then provide a classification. So if it is a policy related or a claim related, so that our we can have a more structured handling of our bot conversation, and we have it in 2 steps. So one becomes the classification, and then the second aspect would be the dialogue which we are receiving. We would have to extract the entities out of it. And that would, that is what would make it proper human-like conversation, because we are able to extract the information relevant to the user. Like, for example, the user is asking a question like, am I eligible for this so-and-so policy? So the chatbot knows, like, okay, for eligibility, what are the things I need to ask? So it the chatbot would ask, okay, what's your age, and what are your requirements for the coverage? So now if the user responds, okay, I am, say, 40 years old. So now the bot should be able to identify and extract the entity, which is the age. So that would be again the second model or the second version of GPT-3 here, which would have to be trained to identify these entities and extracted and handled appropriately. Also, by design, GPT-3 will handle the context and the dependency in the conversation. But in order to have the complete flow, there would be some extra logic in order to maintain the context and ensure that the GPT-3 API is able to manage the flow of dialogue and give a proper response without losing the context of the complete conversation with the user. So all this we can achieve by fine-tuning GPT-3 with respect to these two problems at hand, or the two scenarios we want to solve. And additionally, so it has to be, so when we are creating the data set, we have to be sure, or we have to be very specific about being domain specific. So obviously, if we are doing it for the insurance domain, for example, since that is the example I'm using here. So I would have specific content related to policies or related to claims, the different criteria, and I would prepare my data set in the same line so that this tuned model of GPT-3 would be able to aptly handle my questions related to the specific domain by considering both classification as well as entity extraction. So obviously, when I'm able to handle this, so it is, since GPT-3 is in action here, so obviously it will bring its spontaneity of the conversation. It is not like a decision, hard-coded decision tree wherein you would get a specific branch. So GPT-3 will bring its spontaneity in response, wherein it will become a more human-like conversation. But with the fine-tuning, we will control the and with the other conditions of temperature and the variations to control and bring in a proper context-specific conversation with the bot. Also, with a smaller number of intents, we can efficiently have this prompt and completion pairs set up and train our model accordingly. Now, depending on the case, maybe for some scenarios, we can also go with a few shot training. If it is not a very huge domain and a huge data set we want to train with, and if it's a more conversational chatbot which we are trying to achieve, then maybe a few shot training would also help. Where, in fact, if you would have played with GPT-3, so in the playground, it provides some examples of bots where it has a sarcastic bot and it has a friendly bot. So those are like a normal conversational bot, not specific to a domain. If it is specific to a domain, obviously we would need a much more rigorous training with the domain specific data set. Now, coming to the next model which we want to discuss today, DALL-E. And again, DALL-E has been in news recently because now it is also available as an API to use and play with, just like GPT-3. And being an open API product, this is also a very powerful one. And it is a very interesting one, I would say, where it gives you a different kind of power, you can say. You give a text and it generates images, So it's like, it's a great feeling, and it is an interesting use case to bring into our chatbot and our user experience. So like it is used to generate realistic images, arts, and like with a normal natural language description, you can see how it converts it into a image with whatever it has been trained with, like a 12 billion parameter version of GPT-3, and trained to generate images. And it like it will amaze you with the kind of spontaneity it brings in, the kind of styles it brings in into the images which it generates. And also it has other capabilities, like if you give a image, it can generate variations, it can edit it realistically. So your original image would, like if you want to make some additions to it, it can make it very seamlessly and very cleanly. Also, it can generate variations. So again, this capability brings in so much of so much of possibilities in how you can use this model to bring out your personalization in the user experience. And like I have tried to put in some of the examples here. So of course, the digital, the art industry has like a limitless plethora of professional illustration ideas. It can be used for image variations. So giving an image and trying to get different variations, different ideas out of it. Then if you have played with social apps, so the different augmented reality filters, again, you can become creative there, and you can bring in your different flavors using DALL-E. Another very interesting use case, and we will again touch upon it as we see the example which Shubham will be presenting, is a smart product discovery. And this is like wherever you have like something like an e-commerce platform or a search engine where you're giving user recommendations. So this will be very handy when you would enable the user to either search by like a give an image, and you want to search like I want to get something similar to this. So you give an image and then it will give you recommendations accordingly. Or for example, if you want to like, so another example which I was going through is like if the user wants to like have a view of his own room or his own interiors, and try to like place. So suppose if it's a like a furniture e-commerce platform, and it can actually enable you to, okay, this sofa, how will it fit into my interiors? So giving the user uploads his room photo, and then you can actually place it there and show it to the user how it will look, and those kind of variations. Again, bring in more creativity there, like given some additions. So another interesting example was like how the chefs use different plating. So again, giving ideas there. So all these design ideas, and of course the graphics, the digital art, the avatars for your like bots. So all these variations, DALL-E can bring in much more variety and much more power to it. So yeah, this is just a view of different like artwork by DALL-E, where you can see a cat meditating, and like a tree of life with different animals. So like different representation. This is some interior like a window with how you place the plants, or a variation of a blue book and a glass of water. So how different ways you can place it. So you can see, or a city on Mars, so something from the future. And here again, a variation of face in different artistic styles. So like different things you can do from DALL-E, and it's like our innovation, we can bring in our thought process and see how we can unleash this potential and apply it to the different industries. So we have like tried to bring in some variations and give you a flavor of that here. So this is like generating photo generate faces, which can be the face of your bot or like some realistic faces generated by DALL-E. Then again, if you want to give it like a emoji, so again, for your face, what would be the emoji? So these are all like taken from the net, different examples on DALL-E. Now this again, like maybe identifying a criminal from a side face, you have a front face or the other way. So generating different views of the face, of the same face using one photo. So that could be done using DALL-E. Generating different cartoon characters, different versions of the look and feel, different variations. Yeah, so this was the example of the product discovery, which I spoke about earlier. So we have taken an e-commerce example. So if a user like wants to see a red jacket, so the different variations of that. So how DALL-E can generate, if you give it a visual attributes, the description, it can generate images out of it. And you will see that later when Shubham explains. Now again, the input to output. So if you want to just draw out something and then you want DALL-E to give a realistic image, so that image to output is another capability you can achieve using DALL-E. Now this is an interior example where the same set of elements have been like rearranged to give a different look and feel. And so you can just say that like reorder and give a new feel of. So it's like editing the image and making it so realistic that it looks like just a new look or a new interior for you to make a choice, right? So that is the kind of power this brings in. Again, like different car models generated by DALL-E. Then in education, how it can be used. So when the teacher is explaining a specific example, now instead of going into Google and trying to search for the images, you have this DALL-E app which will instantly give you different variations of the description. So a bird with a red hat and feathers that fade from red to gray, from head to tail. So a good description, and you can see the different variations of the bird immediately. So that is how you can generate such realistic images by giving a detailed attribute problem statement, and it will generate the image. Again, this is a variation of, so you have some image and you want to like bring in some animation or some variation into it. So you can ask DALL-E for that and you can use it. So that is how you can actually bring in the power of GPT-3 with the combination and versatility of DALL-E and make your conversational AI much more powerful. So now I'll hand it over to Shubham to compare with the alternatives for GPT-3 and DALL-E, and also look at how we can use it in the conversation. So over to you, Shubham.
Thanks, Abhilasha, for that great introduction. Am I audible?
Yeah.
Thanks. Let me share my screen. Hi, everyone. As Abhilasha mentioned, I'll be discussing the open source alternatives to GPT-3 and DALL-E. And one of the most popular open source alternatives to GPT-3 is its predecessor, GPT-2. We, of course, also have GPT-J, but then GPT-J is different in the sense that it didn't come from OpenAI. GPT-2 came from OpenAI, so it's a more relevant comparison. And the biggest alternative to DALL-E, the most important, the most significant alternative, open source alternative to DALL-E right now is Stable Diffusion. Let me talk about GPT-2 first. So as I already mentioned, it is an open source AI model which helps you generate text. And when you generate text, that text generation could be just a translation. It could be sequence generation, generating a couple of sentences, generating paragraphs. It could be answering questions. And the great part about these transformer models is, like GPT-3, GPT-2 was not trained on any specific task per se. These transformer models have that capability. The way they were trained for predicting the next word in a sequence. And these models, GPT-2, GPT-3, or other models, other transformer-based models, can be manipulated, can be turned over their head to the required task for you. For example, while GPT-2 and GPT-3 were trained for sequence generation, if you generate the sequence properly and present it as Q&A pairs, then GPT-3 and GPT-2 do the question answering for you in terms of sequence generation. Again, like GPT-3, GPT-2 can be fine-tuned for better response on domain-specific datasets. So, of course, both these transformer models have been pre-trained over a large dataset, over a good amount of gigabytes. However, if you want to adjust these models to your requirement, to your domain, be it insurance, be it finance, be it gaming, something which is not very generic, then you better do a fine-tuning, because that fine-tuning will help your model to understand the style of your domain, understand the vocabulary of your domain, and also present answers the way you want. Now, what's the comparison between GPT-2 and GPT-3? How are these models different, and where are they equally good, or where are the potential? Where is the potential? What are the reasons for making a choice between one or two of them? Between two of them. So, as Scott mentioned earlier, large language models have a ton of capabilities. So they help you with question answering, reading comprehension, summarization, general knowledge, logical inference chains, common sense reasoning, arithmetic calculations, text to SQL conversion, and so on. And as it turns out, GPT-2 is far less advanced than GPT-3 for sure. So GPT-3 is a rather than just being a successor to GPT-2, it was a newbie. I mean, it was a totally new creature out there, right? Not a newbie per se, but a totally new creature out there, which had its own set of functionalities. Nevertheless, if, for example, when you are considering a conversational AI requirement where you have to make a chatbot which has to do some question answering, and if you only have to do medium long range question answering, so this is still more. This is still one requirement which the existing conversational AI frameworks do not support. So, for example, even if you're working with Rasa, if you have to do medium long range question answering, you still need to integrate other systems. For example, you can integrate GPT-2 with Rasa, but the point is those systems wouldn't support sequence generation as effectively as these generative models could. So GPT-2 is still good for text generation. It's good for medium question answering and long question answering as well. It depends on how much length you actually want to go for. And it does summarization quite well. And the best part is, since it is open source, unlike GPT-3, which is not, since it is open source, you can customize it and you can run it locally or deploy it cheaply on the cloud. Now, for example, certainly you cannot just run it on your system without having a GPU, but then the point is, so if you want to train it, if you want to fine tune it, not train per se, because these are already pre-trained, but if you want to fine tune it, you would use a GPU. But then once you've fine tuned it, you could fine tune it maybe on cloud as in on Google Colab. But once you've done that, to run it per se, you don't need a GPU, as in for certain tasks at least. So in that sense, when you compare GPT-2 versus GPT-3 for chatbots, GPT-2 being open source, being free, being locally deployable, and of course deployable on cloud, is a better choice when it comes to, for example, answering medium long range answer type questions, doing summarization, doing translation also. But if you want, for example, capabilities which are slightly more advanced, where you go for arithmetic calculations, where you go for logical inference chains. What do I mean by logical inference chains? You have a bunch of paragraphs and you want to conclude from multiple paragraphs an answer which requires just connecting the information which is there in the paragraphs. So when you want to do something of that kind, you better go for GPT-3. However, if it is a medium kind of requirement, you should still go for GPT-2. It's a good choice because it's open source, and you are in a chatbot, you don't always look for those capabilities. But yes, there are advanced cases, as we illustrated in our previous webinar also on insurance, where you need logical inference chains, where you need the chatbot to have real world knowledge, where you need text to SQL conversion, the GPT-3 is undoubtedly a better choice. Now comes the hero in the game, which is Stable Diffusion. So Stable Diffusion is the competitor to DALL-E, and as I'm mentioning this in the category of open source model. So this is an open source model, and this has created great noise in the market, and for good reasons. So it's a text to image diffusion model. It is capable of generating photorealistic images given any text input. And the best part of Stable Diffusion as opposed to DALL-E is, one of the best parts is that it allows you to generate any kind of content that you want. Now it's a double-edged sword. So OpenAI places certain constraints they've been removing for sure, but Stable Diffusion doesn't have those constraints. This was introduced in 2022, and this has taken the market by surprise. And this is, again, as Abhilasha mentioned, this is used to generate images with the help of text. And you can also apply it to other requirements like in-painting, out-painting, and generating image-to-image translations guided by a free text prompt. Now, how do you make the choice between DALL-E and Stable Diffusion? And here one needs to be very careful. Of course, since Stable Diffusion is unrestricted in nature, there is no limit on what you can query. So it seems like more attractive. For example, DALL-E will restrict you from uploading faces of people without consent. DALL-E will restrict you from generating images of politicians, etc. in certain contexts, and so on. Stable Diffusion doesn't have that limitation, so that's better. But then the downside is, for example, if you are in an industry where you are bound by, where you are mandated to follow certain safeguards, right, on the kind of content that you generate, then better go with DALL-E, because DALL-E will automatically not allow you to generate a kind of content which is not encouraged. So coming to the second thing, which is actually another very big reason why to go for Stable Diffusion. Stable Diffusion is open source, unlike DALL-E, which is totally as in behind the curtain. You don't know what's going inside, as in you can't access the code and change it, at least for now. And since it is open source, you can generate more and more sophisticated tools on top of it, and people have been doing so. This was released a couple of months ago, and already there are applications built on top of Stable Diffusion. And since it is open source, it's free for self-hosting. You can host it on your system, and you can deploy it on the cloud. Now, again, as I mentioned with GPT-2, it's not necessary that you need very high capacity GPUs always to do it. Of course, you need GPU to, for example, fine-tune it. So you can fine-tune Stable Diffusion, for example, on certain kinds of images. So, of course, as we discussed in context of language models, fine-tuning helps you understand your domain. Similarly, fine-tuning for text-to-image models helps your models, the relevant model, understand your domain for image generation. That can be done. However, once you've done that, when it comes to using it, there are intelligent ways where you can reduce the requirement of GPU. So it's not as if for Stable Diffusion, you will always have to keep a good stock of GPUs ready. That's false. Post that, I come to the most exciting aspect of today's webinar, and it is demonstrating conversational apps with Flutter. And in this case, in the interest of time, I'll be doing the demo for DALL-E, because for GPT-3 we have already done the demo in the previous webinars. So in this case, the focus will be more on DALL-E, because this is a new thing which we are covering in this webinar. And for that, I will first of all give a brief walkthrough of the code which is being used in Flutter to generate the required to do the required integration with DALL-E. And we'll also make a quick reference to GPT-3 there. But then Raj and I will be giving you a demo on that. So what I show here is, so this is Flutter. So I'm referring to homepage.dart and main.dart here. So when you whichever application you are working on, as in whichever framework you're using, be it React Native, be it Flutter, be it Angular, and so on. So you got to import certain packages which are required for your widgets, etc., to function. But coming to the part of integration with GPT-3 and integration with DALL-E, so what I want to emphasize is the APIs, how they are called, what are the parameters that you provide, and what kind of changes you have to make for different use cases. So, for example, to start with DALL-E API. So DALL-E API is this. So what you do is, if you want to develop a conversational AI system where you put a query in your prompt and it gives you an answer, it gives you an image, then you got to integrate, you got to hit the API. So DALL-E is available as an API, which you can hit. That is what we are trying to demonstrate here. So you use the API which is provided by OpenAI, and of course you provide your API key. I've just placed it dummy. I've put a variable here. You provide your API key. You provide accept in content type format, which is JSON, of course, as with most APIs. And then you provide a prompt which you need to generate your image with. And it depends on what kind of images what number of images you want to generate. Now, it depends on the kind of application you're drawing, right? So if you are, for example, if you are doing marketing, if you want to generate images for marketing, you would generally like to keep the number of n as high, because you would like to choose between the different variations. However, for example, if you want to just turn a person to their left side, right side, etc., so you don't need to generate so many images there, right? It depends on the requirement. And of course, you can choose the resolution. So right now, a good thing which has happened is, and this is very recent, that, and again, this was a comparison, this is a tussle between Stable Diffusion and DALL-E. So Stable Diffusion till now allowed you to generate good resolution images like 1024 by 1024, whereas DALL-E didn't. DALL-E was restricted to 5 by 12 by 5 by 12. But the good part now is that DALL-E also allows you to generate those images. And once you generate those images, you get a JSON response, and from the JSON response, you can parse the URL to pass to your output component. So the idea here is that this is an API, this is priced, and of course, depending on the number of images you will be generating, there are quotas, organization-wide quotas, personal quotas, which restrict how much you can generate right now. But of course, you can purchase credits and expand those quotas there, as in enhance the limits there. When it comes to GPT-3, now GPT-3, as again, GPT-3, there is a GPT-3 API, which has of course been existing for a number of years now. So it's another matter that it became really usable since the last year, because it could be fine-tuned. You provide your API key, and then you get the response. With GPT-3, of course, you have to provide other variables also. For example, you have to provide how many tokens you're interested. Now, this actually depends on what kind of conversations you want to have. When we talk about doing long, medium to long question answering, you cannot simply cap your tokens like at 10 or let's say 20. You would like to generate tokens to a good number. You'd have to keep tokens to a good number. Temperature, now depending on the use case which we have, so whether you want the content to be repetitive, or you want every time a new content to be generated. For example, if you're generating poetry, or if you're generating if you're doing anything on creative side, right? So you, of course, you want everything to be done brand fresh, as in you want the new outputs to be generated. You don't want the same poem to be repeated. However, if you are having a chatbot around insurance, around finance, and other cases where you are not playing with AI for the sake of generating new output, you have to generate proper content. You keep the temperature low, and you also have other parameters like top V, which will penalize based on the frequency of characters which is generated. So of course it helps you in controlling the repetition. Then you have stop words. Stop words are a very integral component of GPT-3, because it is stop words mainly which in fact allow you to control the output of GPT-3 the way you want, where it should stop. Now this is response that you get from GPT-3 based on your requirement is stored, and is stored in a JSON which can be extracted from and passed to your Flutter component for displaying. Now I just want Raj to help me with the demo of this. Raj, could you please share your screen? Raj. Sure. So the rationale behind this demo is to understand how we can use a DALL-E API to generate images, and the same can be done with a Stable Diffusion. Of course, when you take Stable Diffusion, put it on cloud, generate an API from there. There have been actually APIs available for Stable Diffusion as well, Stable Hood and so on. But now I'm restricting myself to DALL-E API. So what you see here is a jacket, a winter jacket. And Raj, could you put the first message, men's winter jacket? So this is something which is already there, this was an input which had been present in the background, but then the result of which was present in the background. But as Raj mentioned a new input, which is man's winter jacket. This changed. So here your text was converted into an image. It was produced on Flutter app. Now, what is this entire thinking all about? The entire thinking, the use case is that, hey, I want to order certain products and I don't know, I actually need to visualize also for that. And there is a way that I can actually just scroll down Amazon or Flipkart or other portals and just try to match from my side. But then sometimes it's not very efficient. I need to actually customize and then send it out for matching. Also, there are cases for example, where you want to design products from your side, right? So you are not necessarily a buyer, you are still as, and you need to design certain products based on certain requirements. So DALL-E will help you there. Raj, could you enter the next prompt? So here you get a men's winter jacket output, but when we add this adjective half sleeve there, right, that itself is modified. Sure. So when you see this, DALL-E right now, this could be pre-trained more to for your specific domain data set, because in this case, the output which it is given could be even made better by fine-tuning. And this is one of the limitations. So when you go for a comparison between Stable Diffusion and DALL-E, what I've seen generally, depending on a domain where you are, what kind of images which you want to do the comparison for, right? So if you are drawing landscapes, so if you're drawing portraits, if you're drawing images for on social media, one or the other model performs better. So DALL-E in this case has changed the image, presenting this as a half sleeve, which in this case is not exactly so. But could you change this to hoodie, Raj? Or maybe this one. So this is an interesting use case. This is more so from the designer side than from the buyer side. So there are cases where, for example, you have to generate patterns. For example, we had to brainstorm on what kind of t-shirts we wanted for our batch. And there was a lot of brainstorming around ideas. Now, when you anyway have these models with a lot of text, right? These models have tons of gigabytes of text. You could actually make use of them to generate the required generate the required images for you, and those images are really a good catch. So for example, when you see this hoodie for electrical engineering batch, you do see a reference to some elements from circuits. If for example you change to the next one, right, Raj, could you please go to the next one? Now here is this text on global warming impact on humans. Now, you are not mentioning about what global warming is. Of course, you need not even mention what humans are, but DALL-E has to generate an output. Now, DALL-E, as most models, large language models, has been pre-trained on a large data set, and it knows what global warming will do. It knows what impact it will have on humans. And what you see here is a good characterization of that, right? So, for example, as Abhilasha was mentioning, if you have to, for example, use these models for education, you could for sure use DALL-E for talking about birds, animals, and so on. But then there are things which we have not foreseen, and this is one of the most important use cases of text-to-image models. So when you talk about concepts like, for example, global warming, climate change, technology in general, the impact of technology, the impact of artificial intelligence, how the world will change, and so on. So there are extensive texts which discuss that. But then, as they always say, a picture is worth 1,000 words. DALL-E gives you that capability to easily devise pictures for those cases, so that you can portray the message much more actively. So what you see here is this quite interesting. So what the image which has been written by DALL-E is one where you don't have greenery in the front part. It's totally broken. It's almost like a broken land. And below you, on the rear, you have on the backside you have your dark clouds, yellowish clouds, and high-rise buildings. But then the human being has been chopped off. The head seems almost chopped off. So what's trying to indicate is that as the world becomes warmer, you will have different scenarios. So you will have there will be cases where you will have greenery, but that will also be followed by hard rocky terrain in the same line, and your industries will coexist with that hard rocky terrain, and your atmosphere will not be attractive at all. So this, of course, nobody would consider it as a pleasant picture. But now when you ask DALL-E to maybe modify this or provide new content, DALL-E will generate the outputs accordingly. So thanks, Raj, for this. So what I wanted to illustrate through this was, so these text to image models per se, these models enable you to not just generate content which you already know. So of course, you know what are birds. I mean, if you want to use DALL-E just for the sake of generating a parrot's image poster, you'll use it for that, of course, also, but not just for that. But you will use it for generating content which you may not, there are different disconnected pieces which you may not have connected in your brain as well. And then because it's already out there on the internet, you can use that language capabilities and text to image capabilities of these models to visualize, as the app is also called Envision, to envision what kind of impact those things are going to have. And these can be used for education, these can be used for marketing. And of course, when we are talking about conversational AI, the idea is that as you talk about, for example, when you talk about visual search, if you, for example, want to, if you want Alexa to order something for you, right? Where you want to also have the feature to decide the kind of product you're interested in. So Alexa right now it's not doing text to image conversion, but if you could integrate that feature, right? So you say something, it generates an output, then you ask it to change it, modifies the output, it does in painting, out painting, and then it allows you to choose and then you order. Those kinds of things. So conversational AI is this domain where you talk with your systems to guide them to a specific direction and get output from them for that. And apps, models like DALL-E or Stable Diffusion can enhance the conversational AI experience by, for example, generating images of people where you not just generate images of, for example, maybe new faces, but also will also be able to turn those faces around, will also be able to show different emojis based on those faces, will also be able to, for example, ask questions related to different domains like product matching, like education, etc. So DALL-E and Stable Diffusion, other models like Midjourney and so on, they are an enhancement to conversational AI for that. And the impact on industries like, for example, education, on marketing, on conversations in general, on e-commerce could be huge when they are deployed in the right direction. So this was it. Thanks, Raj. And now I look forward to answering any questions you may have. We look forward to answering any questions you may have. So I see 6 questions out there. Let me answer these questions to start with. So the first question is, will this AI discussion be used in Salesforce? Or will this be an external app that has to be linked into Salesforce application? So Roshan, as we just mentioned, these are APIs. APIs can be integrated in your application. It's not something which you have to, for example, load on your system and build on your system. You can directly integrate the API. Next question is, can we say that intent matching and topic modeling are the same, as the latter provides us with a bunch of words from which we need to decide the relevant topic? Well, you answered your question in your own way. So in both cases, you try to understand what the statement or set of statements is about. But then in case of intent matching, you are very categorical which one intent is related to. So in topic modeling, you could have a paragraph, you could have a set of sentences, or even one sentence which you try to map to different topics, more than one topic. But in intent classification, you are very clear that that sentence should match to one intent. So the spirit is same, I would say, but then the outputs in topic modeling are a list of topics, and in case of intent matching is a specific precise intent. Third is, can DALL-E's text-to-speech conversion capability be used for creating data visualizations for different domain-specific metrics? Now, the thing is, DALL-E will have to be fine-tuned for that. These text-to-image models will have to be fine-tuned for that. As it stands now, as we have seen earlier, these large language models like GPT-3, they have been enhanced with those capabilities of doing arithmetic calculations, of doing inference and so on. With DALL-E, if you for example have to generate a picture for some graph where you mention in your language that I want a bar graph with height with these values on the x-axis and these values on the y-axis, it will do the generation. But then if you wanted to generate more complex kinds of graphs, right? If you want to really use it in your application for doing that, you need to maybe, for example, try with stable diffusion, which you can fine tune also. The next question is, can you please name some performance boundaries for GPT-3 stable diffusion requests per second for available APIs and reasonable prompts and images, for example? Sure. So that partly we discussed that. So if you go to the OpenAI documentation, they, for example, mention that when you talk about DALL-E, they mention that I think per minute you can't generate more than 20 images, and as an organization you can't generate more than 50 images. So there are those limits. Those are limits which are enforced by OpenAI as of now. But as regards the reasonable prompts and images, the reasonability of the prompt, it's OpenAI which is actually placing strict controls there, and they in fact they have been liberating those controls as well. So initially, for example, you could not edit people's images, real people's images. You could now that's the feature which is allowed, but stable diffusion is extremely liberal. I mean, it's actually too liberal, but because it allows you to generate anything. So the performance boundaries for so when you talk about GPT-2 for example, so now GPT-2 is open source. You can generate any kind of content. So GPT-3 will not allow you to generate hate content for sure, because if you try to, even if you try to use the word kill, right, I'll kill you, and then try to generate something out of it, it will not allow you to do it, right? It will raise an alert there. With 2, it's open. I mean, you can do that, but of course, the team has to be careful around it. What's the maximum limit of tokens GPT-3 can handle at once? So the maximum limit of tokens, it depends on your, so say if you're doing fine tuning, for example. Now in fine tuning, when we are talking about conversational apps, so we have to have a question and answer, right? Now the question itself goes to GPT-3 and the answer is also returned by GPT-3. So those things taken together have to be in a certain range. For example, the number of tokens which your prompt and completion should totally amount to is around 4,500. So you have to ensure that your tokens do not exceed that. So it's not about just your input, how much it is processing, it's also about the output, the total prompt and completion taken together. The images created would, the next question is by Raja. The images created would be the same text given by any at different time. No, so no, these different images would be created. So these, as with any other machine learning model, these models, DALL-E and GPT-3, sorry, DALL-E and Stable Diffusion are not that deterministic per se. Of course they are not, because it is machine learning. So you generate the same, you give the same prompt, it will generate different images. You can try controlling that by seeding. You can try controlling, for example, GPT-2 or GPT-3 with the help of temperature, but they are not designed for that. Next question is by Niranjan. Similar to GPT-3, Davinci, can GPT-2 generate SQL query based on tabular data? It of course can, but the point there is that you need to do a lot of fine tuning. Now, at the end of the day, the whole question comes to be how much time I have, how much amount I'm preparing, how much I'm planning to invest on it. So text to query conversion is something which can be handled by GPT-2 also if you really start fine tuning it a lot for those prompt and completion pairs. As in, they're not called prompt and completion for GPT-2, but then you have to generate some sequences, input sequences and output sequences. However, the good point about GPT-3 is you don't need to even do that. So GPT-3 allows you to do it by default. But yes, for people who don't want to prefer, who don't want to use GPT-3, they can always do that. Just that you need to spend more time and you need to invest on the fine tuning of GPT-2. But it's doable and very much doable. We will have done that actually.
I guess those are all the questions that we have for today. Thank you, Shubham. Thank you, Abhilasha, and thank you, Scott, for that wonderful, insightful session. I hope our attendees find it as interesting as I did. And another quick tip for everyone, all of our past webinars, including all the ones hosted by our presenters from today, especially on Conversational, all of these are already there on our YouTube channel. So it would actually be great if you do check those out as well. And thank you all for all those who basically stayed up till the end of the session for the Q&A round. So thank you once again, everyone. And we'll be seeing you again very soon.
Thanks, everyone.
Thank
Very
you.
good. Thanks, everyone.